Greetings, ladies and gentlemen. This is Freddie Matanzela and welcome back to my YouTube channel. In today's video, we'll be looking at examples on T formula. So now, let's look at example number 1. So saying we are given an integral dx over 4 plus cos x. So now, to integrate this, we first need to remember that when we speak of T formula, we have two different kinds of forms of integrals. So, but the one that we have now, it only has the highest power of 1. So therefore, since we are having the highest power of 1, we can consider that t is equals to 10 half of x. So therefore, if we make x the subject of the formula, we'll say x is equals to 2 the inverse of 10 t. So now, when we derive this, we will say dx over dt is equals to 2 over 1 plus t squared. So therefore, we say dx is equals to 2 dt over 1 plus t squared. Then we also spoke about identities, that in this case we will have an identity of cos, which is equals to 1 minus t squared over 1 plus t squared. And we also said that sine x is equals to 2t over 1 plus t squared. So therefore, now let's try to solve this question. So since we want to eliminate x, therefore we'll say an integral 1 over 4 plus. So where I see cos, I'll substitute our identity. In this case is 1 minus t squared over 1 plus t squared. Therefore, our dx will be equals to 2 dt over 1 plus t squared. So therefore, now we can use maths and say our integral 1 over, let's say we're having a common denominator which is 1 plus t squared. So therefore we know that 4 is over 1. So therefore 1 goes how many times here? It goes, we'll say 4 times 1 plus t squared plus, so this will cancel this, so we'll be left with 1 minus t squared multiplied by 2 dt over 1 plus t squared. So therefore, now simplifying things, we can say an integral, this will cancel this, therefore an integral 1 over 4 multiplied by 1 is 4 plus 4t squared plus 1 minus t squared. So multiply by 2 dt, which will be equals to an integral 2 dt over 5 plus 3t squared. So now to solve this, we can say an integral, let me take 2 out, so equals to, let's say 2, and an integral, so we'll be left with dt here, over here. We know that there's a formula that says if you are having an integral, and let's say a f prime at x over f at x squared, f at x squared plus a squared. When you integrate this, it should give you 1 over a 1 over a tan arc f at x over a plus c. So we're going to apply this formula. So therefore, that means here we have our f at x, we have our f at x, which is equals to a root of 3t. Why? Because here we are having, so let's say this is our f at x, and let's say our a will be equals to a square root of 5. Why is that? It's because of, if I come here, let me use a different pen. So if I come here and substitute this, so that means I'll have 2 dt over, we said our a, let's say we said our f at x is square root 3t. So when I put them in squared, so a square root of 3 all in squared, it will give you 3, and t all in squared will give you t squared. So therefore, that's why we are saying our a is equals to a square root of 5 and f at x is equals to a square root of 3t. So therefore, I can rewrite it and say, a square root of 3t squared plus a square root of 5 squared. So now we have something like this. But if you check here, we don't have an integral of f at x. So now we would say the integral of f at x, which is f prime x, will be equals to a square root of 3. So now, rewriting this, we would say 2 an integral, then we'll substitute a square root of 3 over a square root of 3t squared plus a square root of 5 squared. So now, this is almost, we need to make this to be the same as this, but here we had 1, so that means I can divide by a square root of 3. So now 2 over a square root of 3, when I multiply it with a square root of 3, it will give me 1. It will give me 2 actually, because a square root will cancel a square root. So therefore, now we can say, we can apply our formula, we can apply this formula, because now we have f prime, we have f at x, and we have a. So therefore, we can say 1 over a, so our a is a square root. So now remember that we have 2 over a square root 3. So multiply by 1 over, let's substitute a. So a is a what? It's a square root of 5. 10 arc. Then our f at x, we said it's what? Our f at x, we said it's a square root of 3t over a square root of 5. We're still on right track, plus c. So therefore, that means our final answer will be equals to 2 multiplied by 1 is 2. And a square root of 3 multiplied by a square root of 5, you'll get a square root of 15. 10 negative 10, an inverse of 10 actually. Then a square root of 3. So where I see t, I will substitute that t is equals to, we remember we said that t is equals to 10 1 over 2x. So where I see t, I'll substitute 10 1 over 2x over a square root of 5 plus c. So this will be our final answer. One example 2, that we are having an integral 1 over 1 plus 2 sine squared x dx. So now to integrate this, let's look at our highest power of our trig function. Our highest power is 2, so that means we need to consider that t is equals to 10x. So in this case, it won't be 10 half of x, it will be 10x. So therefore, if we make x the subject of the formula, we'll have an inverse of 10t. So the derivative of it will have dx over dt, which is equals to 1 over 1 plus t squared. So therefore, if we make dx the subject of the formula, we'll have dx is equals to dt over 1 plus t squared. Therefore, in this case, remember we have identities. So in this case, our identity of cos x will be equals to 1 over a square root 1 plus t squared. And an identity of sine will be equals to t over a square root of 1 plus t squared. So now, since we have identified every information that we need, so let's substitute t instead of x. So let's say an integral 1 over 1 plus 2. So where I see sine, I will put t over a square root 1 plus t squared, all in squared. Where I see dx, I'll put dt over 1 plus t squared. So therefore, let's do our math. So if we do our math, we'll say 1 over 1 plus 2t squared over 1 plus t squared multiplied by dt over 1 plus t squared. So therefore, we can say now our integral 1 over 1. So now let's look at our common denominator. So let's say 1 plus t squared is our common denominator. So we know that 1 is always over 1. So therefore we will say 1 plus t squared plus 2t squared multiplied by dt over 1 plus t squared. So to summarize this, we would say an integral, this will cancel this, so we'll have 1 over, so these are like terms, 1 plus 2, 1 t squared plus 2 t squared will have 1 plus 3t squared. So therefore now we can integrate. So to integrate this, we will say our f at x is equals to a root of 3t, and our f prime at x is equals to the root of 3. So to substitute this, we will say an integral a square root of 3 over 1 plus a square root of 3t all in squared. So therefore we need to make this to be the same as this. So that means we'll divide by 1 over a square root of 3. So now we can apply the law that says if you are having f prime at x over f at x squared plus a squared, it's equals to 1 over a tan arc inverse of 10 f at x over a plus c. So we're going to apply this. So if you apply this, we'll say 1 over a square root of 3 multiplied by 1 over, our a in this case is 1, 10 inverse, our f at x is square root 3t over, our a is 1 plus c. So to write this in an acceptable way, we will say 1 over a square root of 3, 10 inverse a square root of 3. So where we see t, we'll substitute 10x plus c. So this will be our final answer.